Welcome to Excel 2010 Statistics video number 25. Hey, if you want to download this workbook, Excel 2010 Statistics Chapter 3, click on the link below the video. Hey, we're on the Sheet tab Topics, and we're starting Chapter 3. Hey, descriptive statistics, that's what we're doing here. Tabular, graphical, and numerical summaries of data. All right, so Chapter 2, we did tabular and graphical. Now remember, we have a huge data set. It's hard to make sense of all that raw data. But what we did last time is we did frequency distributions and the like, and various charts. So tabular and graphical, we're taking the raw data, organizing it in some way so that it's useful information. Summaries of data, creating useful information. So Chapter 3, what are we going to do? Same thing, descriptive statistics, but now we're doing numerical summaries. So for example, we're going to be doing calculations like an average, mean, median, or mode, and things like standard deviation. They're all going to be calculating numbers. And in a single number, there'll be some sort of summary. So here's a list of what we'll be doing. Lots of fun, exciting topics in this chapter. Let's go to the sheet mean. Oh, that is so mean. Now, our first topic or broad topic for Chapter 3 is the topic of typical values. Now, a typical value, why do you need a typical value? Well, just imagine. Here's a bunch of scores from a statistics test, and your teacher walks in the room and goes, hey, on the last test, someone got a 60, a 68, a 76, an 84, a 55. Well, that wouldn't make any sense, right? Really, what the teacher does is they come in and say, hey, on the last test, the average score was 71. Now, what they really mean is the mean. The mean is the word we use in statistics that represents the standard everyday word average. But the teacher comes in and goes, hey, the average is 71. Immediately, in one single number, you get a number that represents all the data points. It's a typical value. So typical values are very important. They are statistics that we calculate so that we have one number that represents all the data points. That is a very important idea. Now, most of us just from everyday language know that what an average is. But it's very important to realize that in one single number, we have what's called a typical value, or a value that represents all the data points. OK, so mean, add them up, divide by the count. It's good for quantitative data, right? You can't add up the words Toyota and Honda, right? So mean is good for quantitative data when there's no extreme values. Extremes mean very low or very big. In that case, we'll see that median is more appropriate. And so in Excel, we'll use the average function. All right, let's calculate our mean test scores, average. So I create my formula. I click there, Control Shift down arrow, and then Enter, Control Enter. All right, so 67.45. The teacher comes in and goes, the average on test number 2 on probability is 67.45. We can use this average to compare our scores and gauge how well we did. Oh, yeah, that's why the teacher says it, right? The average is 67. Well, if you get an 81, you know you're above average. If you get a 65, you know you're slightly below average. All right, so one example, very useful for test scores to have an average. Here's another example. We have a sample this time. Let's say this was all of the scores from test number 2 last quarter. So that would be a population. That's all the numbers. But oftentimes, and in fact, most of what we'll be doing in this class and out there in the real world, you don't have all the numbers. You take a sample and then calculate some statistics. Right? You can think of a simple example. Can you count all the fish in the sea? No way. So what do? You take a sample. So here we have weights, ounces of salad bags from a filling machine. So imagine a machine that's filling spinach or lettuce bags, and they're supposed to be 10 ounces. Well, you go out and you get a sample. And there they all are. Well, here's all the data points, but we need a single number to help us figure if the machine is actually calculating accurately. So we'll use an average. Remember, an average is a typical value. We're going to have one value that represents all the data points. So 10.1845, right? So we can use this average to help us estimate whether the machine is filling correctly. And in chapters 7 to 10, or to 7 to 9, we'll see how to use hypothesis testing to do that. But an average, a single value, represents all the data points. So mean. Let's go over to the next sheet. It's S or P, sample or population. These are the terms we'll use. If the measures are computed for data from a sample, they're called sample statistics. So our salad weights, this was a sample statistics. It's because we calculated it from sample data. Here, this was a population parameter calculated from actual population data. Population parameters when you calculate some measure from all the items. Since we're going to do a lot of sampling, and in this class, a sample statistic is referred as the point estimator of the corresponding population parameter. That's just the fancy terms we use, right, in statistics to say, hey, we took a sample and we'll use it as an estimate for our population. All right, let's go over to the sheet mean, P or S. Here's some notation. Sample mean, population mean. Here's our formula. That thing right there is called X bar. That's the symbol we use when we're calculating the mean from a sample. This symbol right here is the Greek letter mu. We'll use that to represent our mean when we're calculating from population data. All right, so sigma x sub I divided by little n. Sigma means add. X sub I. Notice I have listed all the x's here. X sub 1, x sub 2, x sub 3. The little I just says how many there are. So there's all of our sample data points. And the n is what we use as a variable letter to stand for sample size. Down here, same formula, just different notation. Mu, sigma x sub I, divided by big N. That means we're getting it, all the data from the population. So mu, all of the items. This is a small example right here. We calculate 10.87. Here, just some of them. We pulled out just some of them. We did a little sample, and we calculated X bar at 11 bucks. So the sample statistics sample mean X bar, 11 bucks, is the point estimate of the population parameter, population mean mu. Now look at that. I'm always known to misspell and can't type and all sorts of things. All right, but are they the same? It'd be extremely rare if you go out and take a sample and this X bar is exactly equal to mu. So this is our oftentimes best estimate from our sample of the population parameter. All right, so mean. This is a way of getting a typical value. In some ways, think about it. If we go back over to the sheet mean, right? Here's something we can all relate to. Mean test score. That one number represents all the data points. In some ways, it's like a typical value, or you can even think it's kind of like the one in the middle, right? Now, we mentioned that when we're calculating mean, this is a great calculation, an average, right? When there are no extreme values. We want to now go look at an example when we have some extreme values and see that using the average function or our mean calculation is not so good. Let's go over to median. I'm going to click on the sheet median. Now let's just look at our data here. House prices. I'm sure you've heard it somewhere in a newspaper article, on television, a radio on the ad. The news person says the median house prices in Seattle. The median house price is, boom. So median, they always say median instead of mean or average. All right, so we're going to see this is a second way to calculate a typical value, or in this case, it's really the one in the middle. Now notice, big value, a $2 million house, a $1 million house. Sometimes with salaries, you hear people say the median salary is, and the reason why is there's some really big values. Let's go ahead and see what would happen if we calculated the average. So I'm going to come up here. Notice I said average because that's the word you use in everyday language. I'm going to calculate the mean. I'm going to highlight this. 392. All right. So now we use that in our discussions. The person selling you the house in a particular neighborhood says the average is 392. The news report or the latest economic data calculator about Seattle or whatever area says 392,000. That's the average. Well, what is happening when you calculate a mean is you add them all up and divide by the count. So it makes perfect sense when if you have a couple really big values, it's going to drag the average up. So an alternative to calculating mean is to do median. And here's how you do it. You sort them and take the one in the middle. So let's see how to do this. I'm going to keep this data unsorted, and I'm going to sort this. I'm going to come here. Notice blanks all the way around, as we've been doing all in this class all the way through. Right-click, sort, and I'm going to do whichever one. It doesn't matter, A to Z or Z to A, because the one in the middle will still be the one in the middle. Now, I want to highlight all these. And I want you to notice something down over here. See, it says in the status bar, count 20. That's one way to figure out how many items you have here. Well, how are we going to calculate the one in the middle? I'm going to actually highlight 10 and add a color, and 10 and add a different color, right? Well, there isn't one. It's actually right in between there. No problem. With even number samples, you average the two in the middle. So I'm going to add like red here. So I'm going to come up here, equals average. And that's how you calculate the median. That is the physical method of calculating the median. It is a great way to get a typical value because it is positionally the one in the middle. Another way to think about median, right? There's half of them there and half of them there, right? And the one we have is right in between. Wow, that means this number right here, 195,827, there's exactly 50% of the values below and 50% of the values above. All right, but do you think there's a median function? Absolutely. And guess what? I am not going to use the sorted data because you don't have to go through the actual physical process of calculating the median. I'm going to highlight the unsorted data. And of course, it'll come up with the same number. Now, let's compare here. There you go. There's a few big values when we calculate the mean that pull the mean up above the median. Anytime you see this relationship, meaning median, the positional one in the middle, and mean, anytime the mean is bigger, you know there's a few big values pulling the average up. The reverse would happen, or the inverse would happen, if we had a few small numbers. So the reverse would be if the mean was less than the median. We know there's a few small values pulling the mean down. All right, so median gives us a more representative typical value to use in discussion and ads because it's not affected by extreme values. All right, we can do the same calculation, set of calculations over here. There's the average, and here's the median. Oops, I already left that there. So for the salary data, same situation. We know that there's a few large values pulling the mean up. Median gives us a more representative typical value to make your decision. So imagine you were looking at this business, right? and you wanted to decide whether to work here, well, there's the mean, there's the median. This is probably more representative. It's the one in the middle. Typical, there's a few executives being paid a lot. Now, it's also useful to just calculate both, right? They're both summarizing all the data points and giving us a typical value. Now, let's just take a look at this example to see technically what happens. Over here, we had an even number. What happens here? We have an odd number. So there's 10, 10, right? And then we actually do have one exactly in the middle, right? So here, again, if there's an odd number, you just take the one in the middle. And is that what it did? Oh, I forgot to sort it. Control Z, Z, Z. I'm undoing with Control Z. Right-click, sort. Zoop. Actually, let me do this one a big to small just to show you that it doesn't matter. Right? So there's 10, and I'll color that one yellow. There's 10. I'm looking down here. Color that one orange. And then the one in the middle. Oh, look at that. It did it just fine. And these are biggest to smallest. Over here, we did smallest to biggest. All right, so the median. Our second measure for calculating typical values, and it's good when we have extreme values. Let's go look at our third way of calculating a typical value. And there's lots of ways, but these are the most common. I'm going to go over to the sheet mode. Now, what in the world would you do with data like this? And actually, I think we already hinted at this a few times already in this class. This is ordinal level data, or more broadly, remember, categorical data means either nominal, like car names or eye color, or ordinal, meaning it's some word, right? But there's some order to this, right? So rate your professor data here. How in the world do we calculate an average? Oh, well, you can't add them up and divide by the count because actually, if we had some numbers for ordinal level data, you could sometimes. But forget it. This kind of data, you're not going to be able to do this. Oh, yeah. We count how many OKs there are, how many good, how many great, how many bad. And whichever one occurs most frequently, that will be considered the mode and our typical value. Again, typical value is a more general term that means average, right? So when you have categorical data, we need to count and calculate which one happens most frequently. Now, check this out. We could easily do this in a pivot table, right? You could also, if you have all of your words or elements listed here, we can simply use the COUNTIF function. And there are a few ways we can calculate mode when we have categorical data like this. But the COUNTIF, or a basic pivot table, is great because then, you can count every single item and see all of them. The reason that this is good is because sometimes you'll have more than one mode. Now, let's go ahead and finish this formula. I'm going to hit F4 key to lock this as I go down, comma, and then the criteria is 1 to my left. Control Enter, and copy it down. All right, so really, using the COUNTIF or a pivot table, we'll do a pivot table in just a second, is really a great way to calculate the mode when you have categorical data like this, because then you can see all of them. If there happens to be a tie, which we'll see an example of in just a moment, then the COUNTIF or pivot table is a great way. Well, we can see, oh man, I have been doing a terrible job. I better 8 bad, 6 OK. Ooh, I better try and do a better job here. Oh no, so this is going to be our mode, our typical value, right? And calculating a typical value, right? If you count them and this one's the most, that means most people thought that selected the bad category here. So this really is, using common sense, the typical value. Most people said bad. With nominal or ordinal data, we have a way of calculating a typical value. Now let's go over here. And I want to click on the sheet Mode 2. Now, here we have a data set. It says Legos set sold during Christmas. each time a toy is listed, it means we sold it, right? So we can see here we sold 2 of these 6166 large brick box building blocks, right? So we have this huge list, and all we want to do is count and find the mode. Which one did we sell the most of? Which of all of these toys, right, which was the most popular? Which did people like the most? What's the typical value? All right, now I already did it here with a COUNTIF, but I want to do this one with a pivot table. Now, if you get a data set like this, we saw last chapter how to use advanced filter to extract a unique list. So then you would have a unique list here and then formulas. Now, that's fine and dandy, but pivot tables are just a tad bit faster. So what do we do when we create a pivot table? Our data set has a field name at the top, data below, in rows, blanks all the way around. Click in a single cell, insert pivot table, or Alt-NVT. Now I'm going to be risky here. Usually it's nice to put it on another sheet. But just so we can compare, I'm going to maybe place it in F8. Click OK. All right, now, your field list may be like over there. You can drag it wherever you want. You simply drag row. Oh, there's our unique list, just like that. Pivot tables are so magic. Remember, the term we use in the statistics class, these are the elements, right? All right, and then we drag it again down to values, and instantly we should have our count. I'm going to click right here and type frequency. I'm going to click in the pivot table, come up to design, tabular. Click and drag. So there we have. If you click outside the pivot table, click in, that it makes that go away and come back. All right, so absolutely an awesome way to do. Whoops. Wow, OK, so that one's got a long name there. All right, so you can see we got exactly the same results either way. We can clearly see that the kingdom set 794 King's Castle, that is going to be our typical value. At 77, that one occurred most frequently, so that will be our mode. Now, here's another interesting way to do this. This is way beyond the scope of our class. There's a great book called Statistical Analysis, Microsoft Excel 2010 by Conrad Karlberg. And this formula right here, actually, I'll show you in just a moment, but it'll actually tell you which one occurs most frequently. Now, Microsoft didn't put a mode function in here that can look up an actual word and tell you. We had to list our elements and then use the COUNTIF. And then from this 77, we can decipher that this toy right here is the mode, right? Now, here's a formula right here. Again, way beyond the scope of this class. This is an array formula. But just in case you wanted to know, index, the range, MODE.SNGL, and then match, just like that. That will actually retrieve the name of the item that occurs most frequently. This will not be able to deal with situations where there's more than one mode. You can then count using COUNTIF that particular item. All right, now let's go back over to our sheet mode. We have to talk about what happens when you have more than one mode. Now let's go ahead and calculate using the mode function. Now, mode only works on quantitative data, right? It has to be a number. There's mode.mult. We're not going to do that one in this class. That's for multiple modes. There's you can search at YouTube for Excel Magic Trick 761. I talk about the mode.mult. We're going to use the mode.SNGL. Now, the difference between single and multiple and single, is this one will just give you calculate a single mode. So I'm going to highlight this number data. And then when I hit Control Enter, it'll tell you 68. 68 is the actual mode. So that means that 68, the number 68, occurs most frequently. Now, this is our test score data, right? MODE.SNGL will not tell you if there's more than one mode. MODE.SNGL will just report the first one it encounters. A quick pivot table will help reveal if there's more than one mode. Oh, yeah. We can just run a pivot table just like we did for our categorical data. We can use it for quantitative data. It'll give us a unique list or a list of our elements and then count how many there are. So with my cell field name at the top, records and rows, click in a single cell, Alt-NVT. And again, I'm going to be risky and put it on this sheet, say in cell F18. Click OK. Row labels. Instantly, we get a unique list. Each number, even though there are repeats, is listed once. And then we drag down to values. Now, because it is a number, it's pre-programmed to automatically sum. That's not what we want. No problem. We can right-click. We can always go down to value field settings. But in 2007 and 10, you have this great summarize values by and show values as. I'm simply going to say, hey, let's change it to the count. I'm going to click over here. I'm going to type frequency here. And very quickly, we can see, oh, this is called what's called bimodal. I'm going to right-click, uncheck this, show field list. So we very quickly can see, once you get the hang of pivot tables, right, that's just a few clicks. You can very quickly see that we have more than one mode. This is called bimodal. If we had lots of numbers listed with a 3, and that was the one that occurred the most frequently, it would be called multiple modes. All right, so in this video, we calculated 3 typical values. We calculated the mode. Mode is best suited for categorical data. However, it certainly can be used on quantitative data. We calculated the median. That's the one in the middle. Median is great when you have extreme values. And we calculated the mean. The mean is the measure of an average measurement or a typical value. Sometimes they call it a measure of central location. This will be the one that's used most frequently when it's just regular number data, quantitative data with no extreme values. All right, when we come back in our next video, we'll talk about location. Now, location, we already did some measures of location here. All of our averages, mean, median, mode, they're all measurements of location. Which one is in the middle, right? What's our typical value? In our next video, we'll talk about percentiles, quartiles, as other measurements of location. All right, see you next video.